Hello guys, welcome back to another video, and in this video I'm going to solve this problem of the day from leetcode. Search a 2D matrix. Let's get started. You are given an m cross an integer matrix, and its name is also matrix with the following two properties. What are they? Each row is sorted in non-decreasing order. What it means? It means that each row is arranged in ascending order. It is the In the first example it is given here 1 1 3 5 7. It is in arranged in increasing order or ascending order, and the first integer of each row is greater than the last integer of the previous row. If I write next row, it's going to be the first element of the next row is going to be larger than this element in the last element in the previous row. Here it is given 10 11 16 20, so 10 is greater than 7, and in row itself it is arranged in ascending order, so all the next elements will be greater than their previous elements. So 11 16, and there will not be any element that is less than 16 after it, so it is 20 here in the first example. And the next row is similarly, the next row is the first element of the next row, that is 23, is greater than the last element of the previous row, that is 20. It is 23, then 30, then 34, then 60. It is our first matrix given here. Now we will be given an integer target and return true if the target is present in the matrix or false otherwise. We have to search for an element in this matrix. Simply it is saying we have to search a particular element, and they are saying you must write a solution in log of m cross n. M cross n is total number of elements in this matrix, where m is row and n is column. M cross m will be the total number of elements in this matrix, and whenever we try to solve a problem in log n time complexity, it means that binary search comes into my mind. But how can we apply binary search here? We don't have a linear array, we have a 2D array. Now let's find out. We will consider it as a linear array. Can we do that? Yes, of course we can do that, because they are they are in increasing order. And again, if we from this last amendment we go to the next row, then again it's definitely all the elements in this row are going to be in ascending order, and with that too starting from the greater element from this last row, means we can put them side by side. These row we can put them side by side, one after other, and we can consider it like this: 1 3 5 7 10 11 16 20 23 30 34 and 60. At last 60, we can consider it as linear one dimensional array, because if we convert it and convert it into one dimensional array, we put all the rows side by side one after other, we'll get a sorted array. See, it is sorted, all the elements are in ascending order, and we know that when we have sorted array we can apply binary search. It is a prerequisite of binary search. The given array must be sorted, and here it is sorted. Then we can apply here binary search. How can we do that? We will do that by considering it a single dimensional array and then finding out the mid. I will put my left here and right here at the last, and I am going to find the mid. Mid will come somewhere in between, and let's say the mid will be here. The number of elements are 3 cross 4 12. Total number of elements 12 upon 2 is 6, so sixth element will be our mid. 0th 1 2 3 4 5th 6th, this will be our mid. We'll compare that, we'll compare with the given target, and let's see what is given here. Here it is given 3. We'll compare 16 with 3, and as 3 is smaller than 16, definitely it is going to be in this half. This is mid, and definitely it is going to be in this half. We'll eliminate this. We are not going to use that, the other part. And we will search 3 now in this part, starting from the left and till mid minus 1, because we know that we have sorted array, and the element which we are searching for is less than 16, so definitely it's going to be in the first part. But the problem is that we don't have this linear array, but we can imagine this as linear array. And after finding out mid, I will find this element in this matrix by finding the corresponding row and column. Let's find out how I'm going to find this row and column. See, if I write the indexes of linear array in 2D style, then I will get first index will be 0, then 1, then 2, then 3, then 4. Suppose my matrix is going to have 5 elements in a row, means 5 column are there, and it will have 3 row. So the next element will have index 5, 6, 7, 8, then 9, 10, 11, 12, 13, 14. I have a value mid, and its index is 6. But how do I know where it is in my matrix? Let me consider, for if I am taking if I continue this example 1, then it must have 4 columns. I have created here 5 columns. Let me delete one column and write it again. Basically I am just showing here how I'm going to imagine it in 1D form, and work on that particular 2D matrix. So the next element will have index 4, then 5, then 6, then 7, 8, 9, 10, and last element will have index 11. This is the sixth index. This is the sixth index. But now if I write the indices in the 2D form, that is in the form of rows and column, the indexes will be 0 1, sorry 0 0 is starting with 0 0, 0 1, 0 2, 0 3, then 1 0, 1 1, 1 2, 1 3, 2 0, 2 1, 2 2, 2 3. I have that 6. I have found out this 6 by calculating the mid. Now I have to find this 1 and 2, one row and second column. How I'm going to find that? I'm going to find this row using the fact that there are a particular number of columns. If I have 4 columns, then I know that if I divide particular index, that is any of this number 0 1 2 3 up by 4, then definitely all the elements before 4, if I am performing the integer division, if I write here any element 0 1 2 3, I am going to get 0 as the result. I am going to get 0, and that's what I want. I want 0 for the 0th row. And these number, if you focus here, if you have noticed that these number are written here 0 1 2 3. So if I divide the index of the elements of the first row, I will definitely get divided by the column number, total number of columns in the given matrix. I am definitely going to get 0. Let's try it with the another row. What if I divide these numbers 4 5 6 7 by the number of columns in this matrix 4, I'm going to get 1 each time if I'm performing the integer division. 4 by 4 is 1, 5 by 4 is 1, 1 point something, it will remain 1 for integer division, and for 6 also, for 7 also. So for each element in the zeroth row I'm going to get 0 as the row number if I divide it by the column number, and 1 for the all the elements in the second row if I divide it by the number of columns. So from here I got the formula that row number I will calculate by dividing this mid that I have calculated by the column numbers, total number of columns, number of columns in the matrix. So I got the row number, now I want the column number, and for column number I want that for this 0 I want 0, for this 1 I want 1, for this 2 I want column number 2, for this index 3 I want column number as 3. And you might have noticed here I want columns will be from 0 to 3. They are not going to get below 0 and above 3. And we know we have one operator that does that, and that is modulo operator. If I do modulo of any of these number, any of these indexes with 4, it is never going to give me value that is larger than or equals to 4. So we can calculate the column number by using the modulo operator. How? Let's try it. Let's try for these few of these indexes given here. if i if I do modulo of 1 0 1 2 3 modulo 4, as all these numbers are smaller than 4, so I will get again the same number for which I am performing the modulo. For 0 I will get 0, for 1 I will get 1, for 2 I will get 2, and for 3 I will get 3, and that's what I want. I want 0 for 0th index, and I want column number 1 for 1th index, and so on. And let's try with the another next row, and here indexes are 4 5 6 7. If I perform modulo with 4, so 4 modulo 4, definitely it's going to be 0, and 5 modulo 4 will get remainder 1. In this case we will get remainder 2, and in this case we will get remainder 3, because 4 1 times will be 4, and we'll get 3 as remaining as remainder. So I will get 0 1 2 3, and that's what the column numbers here 0 1 2 3. In this way, if we perform this operation mid modulo same number of columns, I'll get the column number for each value. In this way, considering it as a linear array, I can manage this 2D matrix and can find out the required target in log of n time complexity. I have done the same which I have explained here in this code. Let me explain you this code. So here I have calculated the number of rows by calculating the size of the matrix dot size, and here I've calculated the number of columns present in the matrix, and that will be the size of the first element of this matrix. So matrix 0 dot size. Now I have kept these two variables left and right for performing binary search, and left initially will be at 0, 0th index, and right will be pointing to the element at the last index, and in this example it will be at the 11th index because total 12 elements are present here. Now I will continue my while loop as I have done it as we perform the simple binary search on linear array. I have done the same thing. Here I have calculated mid by using that formula left plus right upon 2. It is equivalent to this right plus left minus right upon 2 is equivalent to right plus left upon 2. Now you have here I have calculated the number of the particular row number, and here I have calculated the particular column number, and I've used the same formula which I have shown previously, and here I'm checking that if the element at the particular row and column of matrix is equals to target. Yes, if yes, then I have found it, I will return true. If not, then I will move my left or right pointer, and if the target is greater means that it is going to be in the right part, so I'm going to shift my left pointer to the towards right, so I'm doing here mid plus 1. In the else condition, it is not equal to the target, it is not, the particular number is not less than target, then target must be smaller, then it must be in the left part. So I have shifted here my right pointer in the left direction by doing mid minus 1. If I if i don't find my element here in this while loop, then definitely it is not present in my matrix, then I will return false. So this is the way how I have approached this problem. Now let's submit it, uh, f- um, for showing you that it is working fine. Yes, it has been submitted. Hope you understood the concept, and we'll meet in the next video. Till then, bye bye.